Hey everybody. So today's in this today's video, I would like to focus on doing a string section, and then mostly I want to focus on anagrams questions because anagrams questions are the most common and most popular questions in the programming coding interviews. So mastering anagram is getting close to getting a job in a sense. So let's start with the easy question, valid anagram, and then after that, let's gear towards to medium questions. So the goal of this video is to master anagram questions and techniques that we can use for solving anagram questions. So let's start with this easy question, valid anagram. So we're given two words, so basically two strings, anagram or nagram. And then basically we want to return true if those anagrams, if those two words are anagram. So I'm gonna skip goal settings for this question because it's too easy and obvious. But we need to be careful with the edge case actually. So first of all, as a edge case is if lengths of two words are different, we should return false. Otherwise, we're gonna continue for char s, for char t, and I'm gonna use zip of the s and t. So that Python zip is to traverse s and t from the top together. So let's print out for the sake of everybody's catch up. So zip is very useful when we want to run for loop parallelly for two words, two strings. So I'm gonna comment out, but basically an is coming from both two words, and then what I'm gonna do is so create a dictionary of s, and I'm also going to create a dictionary of t. So for dictionary of s is the char. So what I'm going to do is dictionary of s, to get the char of s, and then plus 1. So that's what I'm going to do. So for the dictionary of character s is gonna be current value plus 1. Similarly for dictionary of t, we're gonna add t of the char. So current dictionary plus 1. Now let's compare those two dictionaries. Nice. So what we're going to do is the checking part. So for char in dictionary of s, what we're going to do is comparison. So if dictionary of s in char is different from, now we're going to get the dictionary of t of the char, then we return false. Otherwise we're gonna return true. Let's do it. Nice. The reason why I use dictionary of t get of the char is because it is possible that this char doesn't exist in the dictionary of t. So as a default, we can define as default. Let's define a 0 so that it doesn't end up with null exception. So this is also taking care of errors. Now we're going to submit this. Very straightforward. Cool. Runtime is good. So runtime is O of n because we're traversing only once. I mean, there are two passes, but basically theoretically, this is O of n. No sorting, no two loops. So this is very straightforward. Now we're going to look at difficult questions. So this is called group anagrams. Let's see. So previous body anagram was easy question. Now this is medium level questions, slightly difficult, but let's take a look. So we're given a list of strings called strings, and then we want to group, actually categorize each words by anagram. So as you see, NAT, TAN, those are anagram because both of them uses A and T. And 8, each T, these are also anagrams. So these are group. And BAT doesn't exist in none of the group. So these are categorized into different groups. And then we also have edge case. So constraint 1, empty input possible. So let's start with the goal setting. Okay, so goal setting is to what? Goal is return group of anagrams. Is there any other constraints? Maybe we can start with the edge cases. So if not, strings return this. Now, what we're going to do is let's do some. I want to start with our kind of like straightforward solution, and then I want to consider if we can optimize the solution. So first solution can be, I think, very straightforward. So forward is that for each word in strings, easy way is to sort. So sorted word is this word.sort, right? Now we know both NAT and TAN become NAT. So in the dictionary of the sorted word equals, actually we want to append those words because these are the list, right? And then we are going to return this dictionary of values only. So dictionary supports values, which only returns values without keys. So we can implement this. So first we need dictionary equals default dict. Now important part is why do we use dictionary and not the this set operation? Because by using default dictionary, we can define what is the default data structure when only T exists and the value doesn't exist. So as a default, if we do, for example, if we do A and T, then we can create list as default. That's why I prefer using default dict of list instead of declaring this. So that's the reason. Default dict is very useful. Now we're going to traverse each word. So for word in strings, we're going to do the sorting. This is the runtime of O of m log m, where m is the length of each word. So now we have sorted, and then we store into dictionary this word. So let's print out actually. Let's see. The dictionary of word. Strings has no word sort. Okay, we can do sorted sorted of word. So sorted is a list as a result. Now I want to create a tuple instead of sort. So let's clean up. As the error message states, sorted word is a list. We cannot store list into dictionary as a rule, but we can store tuple instead of list. That's why I converted list to tuple. Nice. So as you see, when we print a sorted, it's a list. But once we return as a tuple, we can store in the dictionary. Now these are very cool. So we have AET of 3 words, ANT of 2 words, and ABT of bat. This is what we wanted. Very good. So we return this dictionary of values. And then let's actually delete the print. Great. So we're going to submit. Nice. So runtime, what's the runtime of this? So theoretically, we are traversing each word. So this will take of n. So each traversal is of n, where n is the length of strings, but each word needs to be sorted, which is of n log n, where m is the length of word. So actually this is of n times of n log n. So in the result, this is of n m log m. Not so fast. You know, m is the length of each word, and n is the length of entire array. Yeah, so this is not very fast. That's why we need optimization. So what can we do instead? I want to do some improvement and optimization of performance. We need to avoid using sort. So without using sort, we can achieve all of runtime of all of nm, where n is the length of strings and m is the length of word. Can we use? So can we avoid sort? So one idea is to use array of 26 alphabet and count. So counter of each alphabet in each word. Maybe it's better to do some implementation so that you might get a better understanding. But let's do idea 2. So I need to create alphabet is the counter of, you know, therefore this is 0, nothing is counted, and I multiply 26 because there are 26 alphabets. Now we're still going to traverse each strings. That doesn't change, and then we're still going to use the default dictionary as to store, and then we're going to still use a dictionary of value as the return statement. So these, you know, template doesn't change, but what we're going to do is the inside of these, you know, for loop. So instead of sorting, we can count the alphabet, you know. So for the chara in word, what we're going to use is let's do the print out. So we can convert alphabet character into integer using ASCII character. So we can use odd of chara, and let's do this way. So chara of odd. Great. So we can see A starts with 97, E is 101, T is 116. So this is ASCII character. So we want to actually, in order to use this alphabet array of order character minus 97 because A starts with 97. And then we do the +1. So that's the each character. Now we need to convert. So we want to store into dictionary. Okay, so after loop is done, dictionary, again, we're going to use tuple because we cannot store the array, but a tuple we can store. And then we're going to append those words. So let's see. Great. So we're going to submit this. Great. Now a great improvement. So runtime improved from 165 to 124. And for the sake of everybody's understanding, why don't we print out this dictionary to see what's going on? So print. So as you might see, these are the tuple. So each of them looks like a code, like a binary code. So 10000001111. This code represents to eat. So in the first loop, we're going to store eat. Now, as a different word, T also has the same code of alphabet. That's why T is appended next to eat. And then same as T and tan. These have a different alphabet because now we have N. So the code is different. So key is different. That's why tan is stored into different array. So this operation continues. Yeah. And then the alphabet of declaration is declared inside the group. The reason why we do this is we need to reset this alphabet counter in each word. That's why I kind of declared into this. So we actually don't need the first line. Yeah, and then we can submit. Right. Yeah, so that's pretty much it. So as I mentioned, the runtime is of NM, where N is the length of strings of the list, and M is the length of each word, and which is a way better than the first operation of using sort, which is slow. So that's the anagram. I hope this video captures very important concepts of how to master anagram questions using sort, dictionary, and default dictionary, and using tuple to store, and then ASCII character conversion. I think this is a great step to master anagram question and strings question. So thank you so much.